Good evening, all of you. I welcome you all for today's session. In this class, we try to understand classification of elements. Elements are classified into different types based on their VI characteristics. Now we'll see how we can classify elements into different types. The first classification is linear and non-linear elements. So elements can be classified into linear and non-linear. That is the first classification. Second one, we can classify the elements into active and passive elements. Third one is unilateral and bilateral elements. Fourth one is time variant and time invariant elements. Now we try to understand one by one clearly. So first classification is linear and non-linear elements. So when we can say an element is linear or non-linear, we'll discuss now. An element is said to be linear if its VI characteristics follows only one equation of straight line passing through origin for all time t. Means if I draw a curve between voltage and current for that element, if it gives a single straight line passing through origin, then that element is said to be linear. Otherwise, it is said to be non-linear. So all of you must remember this. It must be only one equation of straight line passing through origin for all time t. Then only we can say the element as linear. Now let us try to understand this with some examples. See here in the first diagram, if I draw a curve between voltage and current I, then we got a straight line passing through origin. See, for all time t, it see from minus infinity to infinite. At any time t, if you draw a curve, then it will give you a straight line passing through origin for all time t. So the element having this kind of characteristic is said to be linear. I hope it is clear. Now in the second diagram, if you observe, this is also a straight line passing through origin. If I draw a VI curve between voltage and current, it gives me a straight line passing through origin for all time t. So the element having this kind of characteristics also said to be linear. Now let us see the third diagram. In this, if I draw a curve between voltage and current, it gives me a straight line during from 0 to any time on the right half of the on the right side it is gives me a straight line. See, if I is negative, for example, then this voltage is becoming 0. So it is not a single straight line, the curve is following like this. Okay, so it is not a single straight line. That's why the element which is having this kind of VI characteristics is said to be non-linear. I hope up to here is clear. Let us go with further some examples. Now you see this fourth diagram. See, if I draw a VI curve, I am getting two straight lines. So this is not a single straight line. So the element having this kind of VI characteristics is said to be non-linear. Okay, I hope it is clear. Similarly, if you see in the fifth diagram also, we are not getting a single straight line passing through origin. So it is also a non-linear element. Okay. See here in this diagram, this curve itself is not a straight line. So it is non-linear. Here also for all time t, it is not a single straight line. It is following like this. Up to here it is getting one straight line. From here to here we are getting like this. So it is also a non-linear element. Here we are getting a straight line for all time t, but this straight line is not passing through origin. That's why the element which is showing this kind of VI characteristic is also non-linear. Okay, now let us go further. See, anyhow, this is not a straight line and it is not passing through origin. This element is also non-linear. Here it is passing through origin, but it is not a single straight line. Up to here, one straight line. From here to here, it is changing. From here to here, I am getting one. Here to here, I am getting another one. So it is also a non-linear element. So the elements which are showing these kind of characteristics are non-linear. If the VI characteristics is a straight line passing through origin and it is a single straight line equation, then the element is said to be linear. Otherwise, it is non-linear element. So that is the first classification. We are now second classification. We classify elements into active elements and passive elements. Now we try to know, try to understand what is active element and what is passive element. An element is said to be active if it is able to deliver net amount of power to the external circuit. Otherwise, if it is not able to supply a net amount of power to the external circuit, then that element is said to be passive. So an element is said to be active if it is able to supply power to the other elements in the circuit. Otherwise, the element is said to be passive. So here I listed out some of the examples for active element. Voltage source, which is able to supply power to the external elements in the circuit. So voltage source is example for active element. Current source is also able to supply power to the other elements in the circuit. So current source is also one of the example for active element. Battery is also able to supply power to the other elements in the circuit. That's why battery is also a active element. Now let us see some of the examples for passive element. So an element is said to be passive if it is not able to supply power to the other elements in the circuit. So resistance, inductance and capacitance are the examples for passive elements. Okay, only if r greater than 0, r equal to 0, l greater than or equal to 0, c greater than or equal to 0, then only we can say r, l and c are passive elements. Means this r and l, c must be positive. Okay, now let us see with some examples. See here, I am drawing a curve between voltage and current. So if I see, according to Ohm's law, we know V is equal to I into R. If I want to find R, R is equal to V divided by I. So if I divide V divided by I, if I got positive, see, if I got a slope positive, then element is said to be passive element. See, in this second diagram, if you observe, the V by I, if I find I am getting a negative slope, then the element is said to be active element. Okay. Similarly, in the next diagram, see, slope is positive from here to here, then it is said to be passive element. So these are the some of the examples for active and passive elements. See, even though this curve was in third quadrant, V is negative, I is negative. If I did V by I will get the positive slope. That's why this curve indicates a passive element. Okay. So let us see what are the observations or conclusions we can made from here. If the graph lie on the first and third quadrant, then the element is passive element. So from this curves, if you observe, whenever the graph lies in the first and third quadrant, we are getting the slope positive. If the slope is positive, the element is said to be passive element. So whenever the curve is lie in second and fourth quadrant, then that element is active element. Okay. I hope it is clear up to here. Let us go further. Third classification is unilateral and bilateral elements. See, an element is said to be bilateral if it offers same impedance when the direction of current or polarity of the voltage gets reversed. Otherwise, it is said to be unilateral. See, if I change the voltage polarity and current direction, if I calculate the impedance or resistance, if it is a resistive circuit, then the impedance is same even after changing the direction and reversing the polarity, then that element is said to be bilateral. Otherwise, it is said to be unilateral. Okay, so here I listed out some of the examples for bilateral elements and unilateral elements. Here, if you see, resistor R, L and C are examples for bilateral elements. Diode is an example for unilateral elements. Means if I change the voltage polarity and current direction of a diode, the diode will not offer same impedance after changing the current direction and polarity. But this resistor, inductor and capacitor offer same impedance even though if you change the voltage polarity and current direction. That's why resistor, inductor and capacitor are called bilateral elements. Diode is called unilateral element. Let us go further. We'll try to understand with some examples. See, if you see in the first diagram, if I calculate Z, Z is nothing but voltage divided by current. Impedance is nothing but voltage divided by current. So if I take V1 on the y-axis and I1 on the x-axis in the first quadrant. So if I let us assume that as Z1, Z1 is equal to V1 by I1. I am same taking in the, see what I did here, I am changing the polarity of the voltage, that's why I am getting negative here. This is the point. That's why here I am taking this as minus V1. Similarly, I am changing the direction of the current. Earlier it is from 0 to right side, now 0 to negative side. Means I have changed the polarity of the voltage and reversed the current direction. Then I am calculating the impedance, that is I am naming that as Z2. So Z2 is nothing but minus V1 by minus I1. This minus minus will cancel. Again we'll get V1 by I1. If you observe, earlier during positive direction or positive polarity of the voltage and current direction from left to right, I calculated Z1, I got V1 by I1. Even after changing the polarity of the voltage and reversing the current direction, I am getting Z2 which is equal to V1 by I1 only. Means the impedance is not changing even after reversing the reversing the current direction and changing the polarity of voltage. That's why this element, these kind of character, whichever the element offering this kind of characteristic curve is said to be bilateral. Okay, now let us see further. See in the second diagram, if you observe, see I am calculating Z1 here. See, I am assuming this voltage as 4 and current as 4 also. So if I divide 4 divided by 4, what I'll get? 1 ohms in one direction. Now what I did, I changed the polarity of the voltage, so that's why I got minus 4 volts here, and I changed the current direction, that's why I'm getting minus 4 here. So if I calculate Z2 now, minus 4 by minus 4, again I got 1. So before changing the polarity and current direction, whatever I got, the impedance 1 ohm, even after, even after changing the polarity and changing the current direction, I am getting the same impedance. So this element is also bilateral. Now you see, for example, I am taking different voltage magnitude here, 8 volts at 4 amperes during one direction. So if I change reverse the direction of current, so the current becomes minus 4, and I have changed the uh, polarity of the voltage change, but the magnitude is minus 6 here. So minus 6 by minus 4 gives me 3 by 2, which is not equal to 2 ohms. So here, after changing the direction of current and voltage polarity, I am not getting the same impedance. That's why this is called unilateral. Okay, let us go further. So let us try to have some conclusion. Every linear element is bilateral, but the converse is not true. Means if the element is linear, then we can say it is a bilateral element. But if the element is bilateral, it need not be linear. Okay, so let us go with the last classification: time variant and time invariant. So an element is said to be time variant if its VI characteristics changes with the time. Otherwise, I can say that element is time invariant. So if the VI characteristic of a particular element is changing with time, then I can say it is a time variant element. Otherwise, I can say that element as time invariant. Let us try to understand with the example. See, if I draw the VI curve at a t is equal to t1, I got a curve like this. Okay. Now again I am taking voltage and current readings at time t is equal to t2. If I draw the curve, I am getting another curve which is changing, means the VI characteristic is now changed from when I change the time instant. So if the VI characteristics is changing with time, then it is said to be time variant. So the element which is offering this kind of characteristics is said to be time variant element. Okay. Okay. I would like to stop here for today. Thank you all.